Okay, so this screencast is going to look at covalent compounds, specifically give me a minute. I do struggle with the pen sometimes, don't I? Covalent compounds, remember, are between nonmetals. And we are only going to be concerned with covalent binary compounds. Okay, so only two elements, right? At the end of the screencast, we should be able to determine the formula given the name of a covalent binary compound or the name of a compound given a formula. And the rules are different than they are for ionic. So just look at a couple of examples. Here we have NO, one nitrogen atom bonded with one oxygen atom, and we call this nitrogen monoxide. Little different, we have P2O5, two phosphorus atoms bonded with 5 oxygen atoms, and this is called diphosphorus pentoxide. Right, if you notice, there are prefixes used, except when this first element is just 1, and then there is no prefix. Those are the rules in a nutshell. Why do we have to use these? Because two nonmetals can form more than one compound. Okay? For example, nitrogen and oxygen can form all of these compounds. So we can't just name it nitrogen oxide because we wouldn't know whether it was NO, NO2, N2O, N2O4, or N2O5. So because nonmetals can form two or more compounds, lots of them, we have to use these prefixes to tell us how many of each atom is in this compound. So what are the rules, you may be asking yourself? Well, the rules are you write the name of the first element. You add a prefix only if there is more than one. Then you write the name of the second element, changing the ending to IDE. So this is similar to the ionic compound. The second element always gets a prefix. First element only if there's more than one. Here are the prefixes you need to know. Oops, I can't put a square. All right, these are the prefixes you need to know, i.e. you need to memorize those. Number of atoms is 1. It's mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. You need to know that those are the prefixes and they stand for this many number of atoms. All right, so again, name the first element, name the first nonmetal as an element, only use a prefix if it's more than one. End the name of the second nonmetal element with IDE. Always use a prefix with the second. Only use a prefix with the first nonmetal if there's more than one. Okay, so let's quickly go through some steps. I have SO3. Hopefully you can identify that the first nonmetal is S, sulfur. The second one is oxygen, but we're going to use the root plus IDE, so that would be named oxide. There's only one sulfur, so I don't use a prefix. There are 3 oxygens, so I'm going to use the prefix tri. The name is sulfur trioxide. Let's look at an example. It's a little bit more complicated. P4S3. Identify this first nonmetal as phosphorus. The second one is sulfur, but since it's the second one, I'm going to call it sulfide. The phosphorus has 4, so it's tetraphosphorus. The sulfide has 3, so it's trisulfide. Practice, if I were you, I would pause the screencast and name these, and then check if you're right. So pause it now, and then let's see if you're right. Okay, so CO, carbon monoxide, SO2, sulfur dioxide, Ni3, nitrogen triiodide, SF6, sulfur hexafluoride. Guys, be careful with fluoride that you do use UO. Dinitrogen monoxide, 2 nitrogens, 1 oxide. Writing formulas. Okay, so you just work backwards. If you want, go ahead and pause, and then we can see if you're right. I'll step through at least the first one. Okay, so looking at this first one, phosphorus tribromide. Phosphorus is a P. There is no prefix, so there's only one. Bromide is Br. It says tri. That means it gets a 3. Carbon tetrachloride. Carbon, no prefix, so there's only one. Chloride is Cl. Tetra is 4. Dihydrogen monoxide. Hydrogen, there's 2 of them. Oxide, only 1. Ooh, that's just water. People really don't call it dihydrogen monoxide. They just call it water. We got this right. Thus ends that screen cap.